Recording in progress.
About human language, but that aspect, psycholinguistics, is where we talk about language acquisition, language learning. That's the part in linguistics that we are talking about. So basically, I'm trying to say that spoken language is not the only one. Even a person who cannot speak, or somebody who has problem with, say, some organ in the mouth. Okay, suppose they went to a dentist, the tooth is removed, now they are unable to speak. It's not like if you don't speak, you don't understand language. You still understand language. A person who cannot speak can understand language, right? So this is a unique ability of humans. Okay, and if I ask, what do you use language for? This is the general thing. You use it to communicate ideas, opinions, sentiments, information. So the whole exchange, information exchange, or communicating any feeling, is through language. So for us, language is a vehicle to do this. Now, what are we doing now? As I'm talking, you are decoding, right? You're decoding what am I saying, so that you are trying to understand what I'm trying to express. Similarly, if I ask you a question, like I said, am I audible? And there was a response, yes, right? So there is a response to that. So once I say something, there is analysis of that, and then the response tells me that you have understood it, right? So and then to express that understanding, again, the other person, so there is a speaker, there's a hearer, right? And the speaker becomes the hearer, hearer becomes the speaker. This is how we keep talking. So so this is what we are trying to do in NLP also. We are trying to decode the language. We are trying to generate the language. So I skip this. Basically, linguistics, we are studying human language, and we try to understand the context. So with the context, the meanings changes. The meaning of the word changes. A word may have many meanings. A sentence may have many meanings. The context is what tells us in that particular situation who has spoken, to who the meaning changes, right? So context becomes very important when we are talking. A simple, you can also look around. We have a finite number of rules with which we generate infinite number of sentences, right? All the sentences I am speaking today or you are speaking today, they were not taught by us, by our parents. They were not taught by our English teacher, right? We are learning it based on certain linguistic rules we have in our mind. So that is helping us to generate innumerable sentences today. And in the process, we also see that a phrase, a word, or a sentence, depending on the context, will have different meanings. You convey different things. A simple thing like, what is this? If I say, what is this, to say somebody in front of me, okay, they will say, depending on the answer, you will understand what I meant. So what is this? They may say, this is a book. What is this? Oh, I'm sorry, I'll take it away. So when I say, what is this? And they're saying, I'm sorry, I'll take it away. It means, though there's no video here to show that, I'm just saying that the context tells you what is this. So suppose somebody came to my office and left trash in front of my office, and I say, what is this, right? And their response, they are not saying it is trash. Their response is telling, I am sorry, I'll take it away. Okay, so this again, the response to the stimulus by the speaker, that appropriate response is only possible with somebody who has understood the intention of the speaker. So this is the communicative competence we talk about. So one has to know how to talk, where to talk. Okay, sometimes also not to talk. That also becomes important. Not to talk becomes important. See, for example, a child may not know the whole communicative competence, right? A child will be a child, as the child ages, right, as the child becomes older, that's when they learn the pragmatic notions of language. They learn, okay, for example, if two children, small children, 5-year-olds, they are running around, they meet each other, they are cousins, they meet each other, they are running around, okay, playing, shouting, screaming, fighting, right? Now, so this looks normal. So they do the same in a funeral. Somebody is dead in the family and they're running around, screaming, playing, shouting, right? And we are the one, oh, don't do that. You should not behave like that. In a wedding, they do it the same thing. They're running around, screaming, shouting, laughing. It is fine. But when there is a sad situation, it is not fine. These things a child does not know. Okay, we are the ones telling them. So with age, we learn how to use language in appropriate situations. This competence comes with time, with experience, with lots of exposure to language. Now, why I'm trying to talk about this is that a machine is like a child. Okay, when most of you must be engaged in machine learning. So think of machine as a small child who knows vocabulary items, who knows grammatical rules, who knows how to produce sentences, but where to produce, how to produce, in what situation, which kind of sentences to produce, that comes with lots of training on the data. The data should be representative, otherwise the machine will learn only one kind. Okay, so I'm just bringing a parallel between a machine and a child and how we correct the child. Okay, in wedding you are allowing them to run around, scream around. Then in a funeral you are stopping them. So the child is learning, okay, there is something, my family is crying. So when they cry, we should not be running around, we should not be screaming around. They learn something like that. So machine is like that. Okay, the supervised learning is what we are calling today, is like that. So coming to linguistics, we have many things today. Linguistics, I mean, and these are all like 30 years back, 40 years back. This is how we were working on linguistics. Today, most of it, you just add a computational word there, it will be another discipline today. So you have computational sociolinguistics, computational lexicography, computational psycholinguistics, right? Similarly, computational linguistics takes inputs from all of these also. So we had forensic linguistics. Today we are bringing in the computational techniques to do forensic linguistics as well. Okay, the machine readable dictionaries, lexicography is nothing but studying about dictionaries, right? So we have machine readable dictionaries, which are very important for NLP applications. So we have a computational thing, so when we are bringing this prefix computational, we should not forget the theory behind these things. So most of my students, they are in a hurry to have a paper. They are in a hurry to finish their thesis. They don't like to read a lot about the classical papers. They don't like to read a lot about the theories, right? All they want is to do programming, get some results. And when we ask, okay, do error analysis, they just, that is where they fumble, and so I believe there are young researchers in the audience. So having a very good background knowledge on the field you have selected is very important. I have a slide on that. Okay. So we can skip some of these things. So basically, computational linguistics, let me move this. Yeah. So basically, we are talking about analysis and generation, right? And what are we analyzing? We are analyzing from words, sentences to discourse. Discourse is nothing but running text. And then generating, similarly, we generate sentences, we generate speech, right? We synthesize speech. So all these things are under computational linguistics, which of course, again, you can say that they look similar to what is NLP. So let us first understand the goal of computational linguistics is to make computers understand human language, to use technology to build language tools, and use computers to produce human language. So basically, we want computers to speak in our language. So computational linguistics, they focus on the linguistics aspect, right? And then how is it different from NLP? So NLP are more focused on building tools and applications. Okay, so in the earlier session also, someone talked about the tools that we use on everyday basis, right? So those are NLP tools. Now here one small difference between NLP is, even in my second part I'll be presenting, we don't have 100% accuracies, right? But what a CL wants is that computer should understand language 100%. NLP, they are fine, okay, 80% accuracy is fine, 70% accuracy is fine. CL, they're more related to how can we model language, just like humans are modeling language, you know. So the focus is on that. But today, like I had mentioned earlier, we talk computational linguistics and NLP synonymously. And most of the conferences, whether they are ACL conferences, they have, I mean, the papers are not different. CL conferences or the NLP conferences, the papers are similar only, okay? So in case I use the word CL, please understand we are still sticking to NLP only. I don't have to mention this. All of you know what AI is. So it is the study and design of intelligent agents. That's one definition we can say. Now, what is the relation between CL and AI, and where do we see them? Okay, so we see them in computer programs that talk like us, who behave like us. Okay, today we have Cortana, Siri, Alexa, right? So they are showing artificial intelligence and through people voices that sound like people only, right? So this is where AI and CL come very close together and they work hand in hand. Talking about history of NLP, it all started with the development in formal language theory. So we had a Klein-Beckers, Chomsky. Chomsky is the linguist, and then formally representation of language. Okay, that and the development in probability theory, mathematics, statistics, all these influenced the development of natural language processing field. So coming to approaches, initially rule-based approaches was what was followed. And then with the development in statistical theories, probabilistic methods have paved the way in NLP research. So we can see all the OCR or what we are talking today about predictive technology, they are all statistical based only. Then there was a lull in the period, okay, and then the empiricism again returned, and today, of course, most of it is deep learning only. Everybody is talking about neural networks only, but there is also there's also a trend now to go back to rule-based methods. What happens in deep learning is we have large data sets, we send it in something like a black box, we don't know, we get very nice output. What is in the black box? What is happening to the language for the input? We have no idea. Ask someone to do a proper error analysis, we don't know, right? So many people are again planning to go back to the rule-based methods with this hi-fi technology, but there is a inclination towards rule-based. But till then, you know, for languages, especially low-resource languages, it's always good to start with rule-based methods so that we understand our language better. Okay, coming to the whole goal of computational linguistics is we want computers to talk to us in our language. Like we don't want to talk in C language or Perl language. We want computers to talk in Malayalam. We want computers to talk in Telugu. Computers to talk us in English, right? So this use of human language in computer application will benefit the user. Basically, it is we want them to remain machines, right? We don't want them to rule our world. We want them to assist us in our day-to-day things. So I will just show you some of the examples that has been already mentioned. So Eliza was one of the first chatbots in 1966. It was developed. It gave good insight on what a machine can do. It can really talk like a psychotherapist. Okay. But after that, we came a long way. There are many more applications today. And most of the applications, they take in inputs from different disciplines like AI, machine learning, linguistics, philosophy, electrical engineering, psychology, right? And then just like NLP, we also come across terms like natural language technology, natural language engineering. Okay, so even people in AI are working in NLP, but they consider themselves as artificial intelligence scientists, right? So basically what is common here is everybody is looking at language technologies. Okay, whether there is somebody has joined a program in natural language engineering, approaches may be a little different. Okay, approaches may be a little different. NLP is closer to CL, but again here the approach and the goal is slightly different compared to NLP. And then we also have two fields, NLU and NLG. This we keep coming across when we are doing NLP. So we want machines to understand language. Similarly, we want machines to generate human language. So I just to talk about the different levels, we are talking in terms of sound level, we say phonology, word level morphology, sentence or grammar syntax, and the meaning in at sentence level semantics, and taking context into consideration, pragmatics. Then going beyond a sentence, we say is discourse. Okay, so discourse can be just one utterance, but you need a context to understand what it is, right? So discourse is going beyond a sentence. So for example, if I take this one sentence over, okay, I cannot understand what does over mean. I have to look at the context here. So all this helps us to understand what this is. For example, I have given this small conversation. Mother, hey, you left the door open. I'll be leaving in a second. Okay. Now here you see that when mother is telling you left the door open, the son knows, because son already knows that. Okay. And you left the door open. It looks like a declarative sentence, but you can have the intonation that says it is a question. Okay. So you can, even while reading it, it goes like the intonation, it's a raising intonation. You left the door open. Okay, it's a raising intonation. So this is a text, but still you can hear it. Okay. Now, for example, even if it was a speech input, okay, suppose we are doing speech recognition. Okay, so there is a speech converted to text now, and you left the door open. Okay, so there is, the mother is not just stating it. Mother also has a different intention. Mother means close the door. Okay. So here the sentence has one meaning, you left the door open, but the speaker has another meaning. Okay. So this is what we are concerned about, that speaker meaning and sentence meaning may be different. Okay. So you left the door open sounds like, just a statement. Okay. But here it also means that close the door. And the son is saying, I'll be leaving in a second, means I will close the door when I leave the house again. Okay. So the sentence has many meanings. Okay, so we normally, if a sentence is uttered, we call it a utterance. Okay, so here similarly, mother is saying over. Now, what is this over? Over means, if you are just looking at the word over, you don't understand what it is. You have to go back. So this means I'll be leaving in a second. The moment you utter the word second, the second is over, right? It's with respect to time. So mother is just teasing the son, saying it's over, like 1 second is over. So again, you will understand it better if you look at the next sentence. What amma, you irritate me. Okay. So this also tells that mother is teasing the son, who is actually frustrated already because he cannot find the wallet. So this is a everyday conversation where you will see that between mother and child, there were no greetings. But normally when we start a conversation, we have greeting. In this, there was no greeting because you can assume. Okay, so the son must have gone out, has come in, has met the mother several times in the morning already. So there is no good morning, good afternoon. You are doing the such assumptions. Okay. Similarly, a proper behavior will, the son has left the conversation with a bye, but did not have the time to wait to listen to mother's bye. So, so in conversation analysis, which again is part of discourse, like discourse contains more than a sentence, I said, right? It can be a novel, it can be an article, it can be a whole movie review, it can be a conversation. The whole discourse has a structure. So if you're telling a story, there is a structure for that. If you're telling a joke, there is a structure for that. If you're giving a lecture, there is a structure for that. And if you are just chatting with a friend, there is no structure there actually. Okay, not all discourses have structure, but most of the discourse or the text we take for analysis, we look for the structure first. Okay, so, okay. And then if you look at the language tools used for analysis and generation, again, we have different, if most of you are already working in NLP, you know most of this, right? So if you are looking at the discourse level, we deal with co-reference, that is anaphora resolution. You have to understand what the pronouns are referring to. Similarly, named entity recognition, these really create problems. For example, if you have a name like Mahatma Gandhi, it's a name. But suppose it's Mahatma Gandhi Institute of Technology. The computer should understand that Mahatma Gandhi is not a name here or of a person, but it's part of a name of an institute. Or it can be MG Road. MG Road, it should not just analyze it as a person's name, right? It has to recognize it. Similarly, I talked about intention of the speaker, right? That we talk under Dialogue Act. So most of the time, what we are doing is we are trying to look forward or look before, okay, to understand the correct sentence. So here, for example, if you can take anything, okay. So for example, take one of these sentences. It must be in the drawer. Now you want to say what is the intention of mother. It must be in the, so it must be an answer. Okay, it is a answer. And then you look behind, look to the previous sentence. Where is my wallet? This is telling you that this is the answer. Sometimes what is this, you won't understand. You have to look forward. So this study looks forward. Where we in Dialogue Act, we call it forward looking function and backward looking function. Okay, so to annotate with the Dialogue Act, that is the intention, sometimes you have to look forward, sometimes you have to look backward. Okay, so both the things work in Dialogue Acts. Similarly, inference, or you have to understand the intention of the speaker. Sentiment analysis, we will be looking more about it. So what is the sentiment? Like, for example, here when I said, hey, you left the door open, okay, there is no sentiment there, right? But for example, if here I'll be leaving in a second, right? So you can see that the sun is conveying something. Similarly, you irritate me. So this sometimes the words are used. The lexical words tell you the feeling of the speaker. Okay, but most of the times we don't use such words. We have to understand those things with the help of other words. That's the analysis, that's the sentiment that is hidden within the sentences that we are concerned with. Okay, so again, just a little example to show that language is very complex. It is like you can take examples from your own life. There are many a times we don't understand each other. Right? Once we don't understand each other because we may not have the same language. Suppose I speak in Telugu, you speak in Malayalam, we may not understand each other. A couple of days back, I attended a talk because they asked me to introduce the speaker, and then I stayed back, out of courtesy. But I did not. It was all in English. It was all about some topic which I had no clue about. Though I listened to the speaker spoke English. I with no English, I did not understand anything because I did not have the domain knowledge. Okay, so we don't understand each other because we don't have the same language, okay, or the same code. We may not understand each other because we don't have the domain knowledge, right? Similarly, when it comes to contextual information, you may not understand something because you don't have the context. Like suppose you enter office, both colleagues are talking about something, you join the conversation, you may not understand because you don't have the context. So we may not understand because of many things. Okay, now if we want computer to understand us, we have to give all this contextual information. And in what form shall we give them, right? Now, for example, this one sentence, pretty little girl school. This one phrase, actually, this is not even a complete sentence. I can make it, pretty little girl school is near my house. Okay, I can make a sentence like that. But if we just look at this, there are so many, there are like 1, 2, 3, 4, 5 analysis of this phrase, which means girls school, little girls school, or little school. Okay, then pretty little or pretty girl or pretty school. So you are getting like 5 meanings. Okay, where the girl may be very little, or the school may be very little, or you are using this as a pre-modifier for little, like pretty little. Okay, or similarly, the school may be pretty or the girl may be pretty. So we have different meanings. And then when we talk about sentence analysis, for each one you have a different structure. Okay, so this again shows that unless you have this contextual information, you actually know the school looks like this or like this or like this, or the girl looks like this or like this, you don't know what the correct meaning of this, right? So what happens then? So our tools, suppose you have a parser, it will give you multiple outputs. You have to choose one. Suppose we put this in a machine translation system. Okay, you will get like 5 different translations. Then we can do a ranking. Okay, or we can do okay, first analysis is the best analysis, say something like that. Suppose we have to translate this in Malayalam, you will have many meanings. Okay, so in English it is ambiguous, highly ambiguous phrase, and then in machine translation it will give you multiple meanings. Then it is for you to select the correct meaning by looking at the previous context. So these are some of the challenges we face. Okay, I'm just skipping this, just looking at this one example. So these 2 sentences have same structure. Okay, but anaphora resolution is this. Okay, if you have a pronoun, you want to identify the noun it refers to. Okay, Mary promised Sally to go to her party. Mary persuaded Sally to go to her party. If you do a syntactic analysis, you will have same structures. Okay, so do part of speech tagging, you'll have same part of speech. Do chunking, you'll have same chunks, right? Now, anaphorize so part of speech tagging is not helping, syntax is not helping. Then you have to deal it at a different level. So what is telling is these kind of verbs. So just having a part of speech that it is a verb in its past tense is not sufficient. You have to find out what kind of a verb it is. You have to do further the analysis at the verb level to understand here her means Sally, here her means Mary. Okay, so there are different algorithms where her here may refer to Mary, like we have centering algorithm where her will refer always to Mary because Mary is the key subject of the sentence. Similarly, we have again nearness algorithm, which shows that the pronoun refers to the nearest one. Nearest. So in both the cases, it may give wrong results. Okay, so anaphora resolution is another good area in NLP that deals with this at the discourse level. Then again, I'll skip these things. Most of you may be familiar with all the NLP applications. Search engines, we use it every day. Spell checker, grammar checker, question answering system, sentiment analysis, which we'll be talking in a bit. Then Google Lens this is my current favorite, Google Lens. I hope most of you must be using it by now. Google Lens, why it is my favorite is because it does many things at the same time. Like I can just take my, okay, that's other thing, right? Like when I started, we just had a phone that also, a community phone. Like whether it was in hostel or where I worked, the building had only one phone, and if we got a call, somebody will come and call you. You got a phone, you walk 5 stairs down, to take a call. So that was how communication was earlier. The phone. Then came the mobile phones, then came the smartphones. Now the smartphones has everything. It is less of a phone and more of other things, actually, our phones. So the Google Lens has incorporated many things, including machine translation, including handwriting recognition. So I have this, for example, handwriting, you just take a phone, it will convert the handwriting into text. You take your phone, it is in another language, it will translate it for you. You take a phone, you look at whatever flower or animal, or even, you like somebody's clothes, go to a mall, somebody is wearing some fancy t-shirt, you just take your phone, okay? I mean, it is not good, without the knowledge to do these things, but you can also just look at video, anything on your TV. Take a Google Lens, it will tell you what clothes, which brand and which shop those clothes are available, those shoes are available, what is the cost of the, for example, this sunglasses, which brand it is, what is the cost. You will get everything in microseconds. Okay, one app that I'm very much interested in this because it is everything, including OCR, like handwriting. I mean, we struggled. We did lots of work. At least another research group was working on it. Okay, so today we have all this predictive technology incorporated in our email systems, right? So we have more. It is just like in social media. Even in mails. This is my Outlook mail. It is also tells me, so it is understanding the mail also, and it is giving me answers. So this is from a student, and a student is saying PFA for the final projects, please let us know if any changes are needed. And Cortana is telling me, looks great, thank you, looks good, thanks, looks great. So my colleague sent something else and it says will do, thanks, got it. So you can also see that the language is also important. So for a student, it is giving a different kind of a thing, so if we keep using these things, it also customizes our own language. So it understands how I talk to a colleague, it understands how I talk to a student. So similarly, there are lots of benefits of NLP because they are integrated in your mobile phone, in your email systems. Okay, so whether it is spam, like most of us have this spam thing, also spam. So those documents are classified. Most of our spams get directed to another folder. That's also NLP. I will say that is working at that level. So here, again, predictive technology. I mean, I really like this. This is the natural language understanding that is happening. So this is from Facebook. I mean, it understands what is, if something is sad, it also tells me in the sense, tells the user, it gives a good phrases. Now, all this, how did it learn? For achievement, congratulations. For food presentation, it's also giving all this emotion. It learns from all the users together, right? Now, the moment you're on internet, you're contributing to the growth of internet, right? You're also, in a way, contributing to the building of NLP tools. The more we use this, the bot inside the Facebook or whatever social media tool you're using, it is learning. Okay, if somebody has put something, okay, with respect to food item, now food, first it has to identify that it is a food presentation. It says yummy, must, or with the tongue out, so this, because most of the users have used it, when I use it for the first time, it also is giving this to me. Similarly, when somebody says they achieved something, so this is what people have given earlier, and it is giving it as a suggestion now. So all these things are nothing but NLP. And in the car navigation system also we have, and today everything is on your hand, and most of the smart chatbots have speech recognition, language analysis, dialogue processing, text to speech, all of it integrated within the one app. I also just wanted to say that, today we also have many smart homes, smart kitchens, smart appliances in the house, right? And you use only language to control them. I mean, you can also, you do it manually, like, whether it's a dishwasher or washing machine or a light, you can just go and switch on and off. Or there are appliances that are rely on motion sensors. Then automation one, so based on the temperature outside the house, inside the house, or how you feel, it customizes to your liking. Then the voice control, this is what we are interested. Again, you're using, like, remember earlier we said, why should computers talk to us in human language? Like, I would like to command whether it is Google Assistant or Siri or Alexa in the language I speak, right? I want to control. Okay, so this is where AI and NLP come together. Now, all these things are very nice, okay, with today 5G and Wi-Fi technology and all this. Most of the data is on the cloud. Now, with that, the moment we say cloud, with that comes the challenges of security, right? I mean, all our data is in security. Like, I really know some of my teachers who did not want to go to Google Gmail or use Google Docs because they were afraid of security, right? And similarly, in Facebook also, people would, if people are on Facebook like 10 years back, we have been tagging people, right? We post a group photo, we tag everybody. And today we don't need to tag. It has learned, it automatically tags your friends. It automatically, like if you have Google Photos, it automatically makes folders for every person in your pictures. So how has it learned? It has learned from the tagging we had done earlier, right? We kept tagging, and then it has learned. This is how we have helped today. Like, we have very good applications. Like, though my colleagues don't like it, they don't like, because they are our competitors, right? And I really like Google, because we have contributed in a way to, whether it is Facebook or Google, or we have contributed a lot by annotating, right? We were tagging photos. So today, the face recognition tool, if it is really working well, Facebook should thank all the users, right? If Google is working very well, it should thank us, because people like us have been contributing a lot. That said, I mean, in the research world, NLP is a very small thing. Within NLP, if you look at the research that is going on, it's just a tip of the iceberg. There are lots of things to do. Okay, we are just here, somewhere here. Okay, there's a lot more to do in human language. Then, especially, we have most of the tools in English language, or languages, Chinese and German languages, right? But if we have to work in Indian languages, most of the languages don't have many resources. So it becomes our responsibility. Okay, there's a good number of people in the crowd in the session today, so it becomes our responsibility to build these resources for our own mother tongue. And what we need is large corpus. We need annotation schema. We need GUI, so that not everybody has a computer science background or are comfortable with computers, right? So you have to build a GUI. If you are hiring language editors, experts, spend some time to build a good GUI for them to add or edit data. Similarly, everybody building the same tool or same application, it's not good, right? I mean, it's like reinventing the wheel. So collaboration is always good. If there are 5 universities in Kerala coming together and working together to building tools is good. Like, I know people who worked in NLP in Malayalam, but they were based in Chennai, right? From Anna University, AUKBC. People have been working in Malayalam, but it's also good to have people from the same state working together, share resources. So we have many neural network models today for English language, but there are groups that have worked on Indic-BERT also, Indian languages. But because of lack of data, they may not be working very well for our regional languages. So again, augmenting them with more data becomes our responsibility. Then any application or tool should have an evaluation metrics. Otherwise, it doesn't make any sense. Okay, and similarly, ethics. So I see that there is a talk on fairness in NLP. So I think you will learn more about it there. Then reading is really important. See, most of the time when we review papers, we come across papers that are already done for some language. Like, if you just change language, it is not sufficient, right? You have to be much more creative than that. So first, and sometimes you come across a great idea. You want to work on something. You had an excellent idea, and then when you go to do the related work, you see that that idea was already implemented 5 years back. But suppose if you don't read it and you publish it, people will say, "Oh, you are indulging in plagiarism." Right? To avoid all that, even though you don't have an idea, you don't have intention to plagiarize, it is very good to be updated with the latest in the field. At the same time, read the classical literature, say from rule-based, statistical-based, right, to today's neural network models, the whole journey in the topic you have selected. And then, of course, don't stop doing research. Publishing is very important. Okay, a good place to start lists all the conferences, it lists all the journals there, and all the literature is available there, and most of them are annual conferences. So you have the latest, say, in EMNLP, ACL, IJCNLP, IJCN, and all that, and specialized groups also. Just a dialogue, just a sentiment analysis, just a discourse, you'll find there. And then, of course, when you write a paper, what is more important is the related work, of course, beating the state of the art models, that's of course, or at least comparing it with it. And then we cannot just write results, right? You have to share the link to the data you have used, so that the reviewers can verify the results. Right? I mean, you can not just write, put a table and just say that, this was our results. Innovative factor is very important. And then most important thing a reviewer looks at it is, okay, this work is good, but what impact does it have on society? What social impact or what contribution it is making to NLP community? Okay, so these are the things one has to keep in mind when you go to publish your research work. That done, coming to my own work, apart from other things, I also work in machine translation, dialogue system, computational humor, and text classification. So I would like to take a 2-minute break to see if anybody has questions before we go to the second part of the talk. Anyone has any questions? Okay, sorry, Sonal, I'm seeing your comment now. I'll put the slides in the presentation mode. Thank you. There's no more questions. I'll go on then. So, like I said, in text classification, I work on different things, okay? Or at least my students work, okay? I just guide them. I come up with the idea. They are the ones who do the, the hard part is done by them, okay? The easy part of thinking and coming up with a new topic for their research work, for the thesis, MS thesis is my work. But then after that brainstorming, all I do is just guide them to do good research. So basically, these are some of the things, right? And given the time, I will just take up some things. Because there is social media, access to data is much more easier, right? So when we say social media, it can be Twitter, YouTube comments, Twitter, or anything, blogs, everything. Now, this social media data, why is it challenging? Is because the language that is used is different from the language that the models we train on are, like, So earlier, like initial research has always been on newspaper data. Newspaper data is very clean, right? If you look at newspaper data, the sentences are very good. It's very easy to run your part of speech tagger. It's very easy to run your parsers, everything. It's very easy. Look at social media, because these are done by on a everyday basis by people, so people in a hurry or people with all the touch phones where there is again automated things. So there are lots of errors. So similarly, tweets have this character limitation. So people indulge in short forms. Okay, so they may write lots of words in a shortened form, and your parsers may not recognize them. The part of speech taggers don't recognize them. So social media data becomes a challenge. New branch of NLP which deals with social media analytics. We call it social NLP. That's one good area you can explore. So this takes its root from social linguistics. In social linguistics, we look at problems related to language at the societal level. So how people use language, okay, depending on the situation, depending on their background. Okay, same sentence may be spoken by people belonging to higher, people coming from a rich background, people class, So social linguistics deals with language use, taking the social perspective in mind. Now, social NLP is something like that. The social problems are taken, and then for data, they are looking at social media. Okay, so social media. In social NLP, it looks both at the social media as well as the social issues, basically. So some things we have done, like for example, gender bias, okay, political bias, sentiment. So these are the things I will be looking at. Similarly, given the COVID situation, we had worked on clickbait. Today, I'm not going to talk about it, but we have a paper on this clickbait. We collected lots of data actually. And try to clickbait, so they have a different kind of language. Okay, so most of you may be familiar. I'm sure it is there in Malayalam also. So they may say, if you know what Techie did to his wife, you will be shocked. It makes you curious to click on it. If you eat, it will surprise you that if you eat this, you will lose 15 kilos in a week. Right. So to attract people, there are certain kinds of sentence structures that are used. So that's clickbait. Similarly, hate speech based on, because social media gives you this the mask to stay behind some identity. You don't have to reveal your true identity, right? You can use some fake ID, and then you can just use bad language or hate speech against some race or some religion, caste, or all that. You can convey all that by not revealing your ID, right? So it gives people a little bit of boldness to do that. So there are, if anybody is interested, there are lots of data sets on hate speech. There are lots of data sets for fake news. Data sets, you will find them available in GitHub. Okay, in all this GitHub repository, you'll find them. Earlier, I had mentioned, right, collaboration is very important. If we have to collaborate, right, we have to also benchmark them. Like, you have to follow certain standardized methods, standardized practices, like we have this ISO kind, right? We have to benchmark our resources, benchmark all the research to get a good validation for these things. Okay. Now, and then when we talk about social media, India is a country where, many bilinguals are there, multilinguals also, right? It's very difficult to find monolinguals. Like for someone who speaks only one language, it's very difficult. Many people speak more than one language. So there are lots of code mixing happens. And again, we have tools like, say, POS taggers for English. We have POS taggers for Telugu, POS taggers for Malayalam, POS taggers for English, Hindi, for example. But more than one language, and that's the data I'm getting from social media. Now, what do I do? Right? So building tools even to identify code mixed languages, that becomes a challenge, right? We have worked for English Telugu, we have worked for other English Hindi and English Telugu. We have worked on this pipeline. So those are very useful when we are working with code mixed languages. Okay. Now with that, I move to the next part of my talk, which is text classification. Okay, let me just. I have all these small things that are coming in my way. Okay. Yes. Okay. Why I put this picture is actually give me 1 second. Yesterday I was going through once. Yeah. Yesterday I was going through, just changed my page. Can you see it? Okay. I changed my screen. Is it visible?
No, ma'am.
Okay, 1 second. Okay.
Yes.
Yeah, so one important thing I forgot to share about NLP is that, see, this was yesterday I was going to trying to see, whether I can take some data from here. And then I was just seeing, okay, what does it mean, So translation, I told you, translation, machine translation is one of the important NLP tools, right? So see, I don't know the Malayalam, right? So if I just translate this page, I translate it into English. See, in no time, I get everything in English, right? So that way, technology has come a long way. This is another reason why I like Google. Though there is Bing and there are many more machine translation systems. So there are many things like this. I have this on my laptop, right? So we have a different machine translation, like we have this translator systems like Microsoft's, Google's, and then you can compare the translations 1, 2, 3. It's very easy to have it. Like you can just keep it here. Otherwise, if you look at all this, it's very good, right? This is, I'm sorry, I forgot. This is one of the most important NLP tools that we have today. So similarly, like I was just going, okay, like from the pictures, I can understand something, but it's nice to just translate it, and then in a minute, I get what I want to see, It may be a little bad translation, I don't know, but as a non-native speaker, I get the gist of it, right? So this is one tool, and while doing this, I had come across a picture actually, and that's how I wanted to start the talk. So there was this also, like, I wanted to share this. I wanted a translation. I'm happy to be here, okay, to the participants. I want to say that. So I wanted to see this. Now this is the transliteration we have. And now I may not be able to pronounce it correctly, right? If I want to say, Ivite untairikunati nan santushtanan. So, but I can. Could you hear the audio?
No.
Okay, so anyway, you get it. So there is the audio file also, which tells me, the correct pronunciation. So this is, we have ASR, we have TTS, all that. Okay, so that I'm very happy with the progress NLP has made. And why I went back is that, I came across a article in Malayalam, and it had this picture, about some economy. That's other thing, right? Stock predictions is another thing that NLP does, based on lots of data. Again, reading the related news. You can use NLP techniques, the latest, not just a deep learning, but TensorFlow, all that you can see to study stock predictions. We come to our topic, text classification. So basically, text classification, we have, so I'm just using this analogy of lots of fruits, for example. Now I want to classify them. So what am I doing? So there is this unstructured way where there are some grapes here, there are some grapes here and here. Now I have sorted them out neatly. Okay. So this is what I'm trying to do. So see, please, when I say I, okay, please don't think it's I as Radhika, okay, I as a user, I as a researcher, okay. So basically, we try to put the unstructured data in a structured data, okay. So we are trying to classify them, okay. So we're neatly classified, like, whatever bananas and orange apples, we are separated out. Then what do? Multi-classification. So we put them in separate buckets. This is the multi-classification we are doing. So among the structured ones, again, we are trying to sort them out. So this is based on colors, right? We have sorted them out. Now in binary classification, what do? Now I have a bunch of fruits and vegetables. Now in binary, I want to separate them out as fruits separated from vegetables. This is the binary classes we are talking about. Then we can talk about other types by looking at features. So maybe this is not good enough. I will look at colors. Okay. So all purple colors, green colors, orange. So this is one way of sorting them out. So I can do what is red and the rest. That is also possible, right? I can say a presence of hate speech and rest. Presence of humor and the rest. Presence of positive sentiment and the rest. I can do it that way. Or I can do binary, like the previous one, positive, negative, right? I can do any kind of classes, okay? And then I can do a little further now. I can look at the, not just at the word level, not just at the sentence level. I can look at a little deeper. I can look at the emotions. I can look deeper into the intention of the speaker. I can look at sarcasm. For example, in sarcasm, what happens? The sentence looks positive, but the sentiment is negative. Okay, so for example, in a movie review, we can have a positive sentiment like the movie is great. We can have a negative sentiment like the movie is bad. So this is a positive and this is a negative sentiment. But sometimes you also have sentence that actually has negative sentiment, but the sentence is positive. Like I can say, if you have lots of money to waste, watch this movie. Now watch this movie means a positive sentiment. But there was a condition there. If you have money to waste, watch this movie. Right? So there you have to go a little deeper. Only the surface sentences are not sufficient. You have to look beyond the colors. You have to look beyond the shapes. You have to look at the taste also, right? Similarly, among the vegetables, you want to see which are root vegetables, right? You are going a little deeper into that. So this is the, so again, when you are looking on text classification, you can look at the hidden things like tastes in this example, like an analogy I said, you can be, sentiment can be just positive, negative, but you can go beyond and look for happiness, sadness, anger, frustration. You can look at all those things. So our main reason of emotion-based text classification is that, okay, as based on this, there are works where people also worked on. Earlier I had given, right, in the suggestions, you also get emoticons. Like which emoticon goes with what? How do you do that? You have to work at the emotion level also. Now, for all this, we are bringing in the word embeddings. This is the starting point to do the text-based analysis. So, word embeddings capture both syntax and semantics, the meaning relationships, okay, in the vector space. Now, this is a two-dimensional vector space, right, where we have grouped the vegetables and fruits. Okay, this is the picture I took from Google, of course, not mine. And then you, in these two dimensions, you are showing the similarities. Like if we have, if I have to do this distributional semantics for, say, pig and cow, and then I just say plus pig plus pork minus beef, it gives me a result of cow. Okay. So similarly, if I have a king minus man plus women, it gives me queen. Okay. Paris minus France plus Germany, it gives Berlin. Now, this is able to do because it knows that king is plus male, man is, okay, plus male, women is minus male. Similarly, Paris is capital, France is a country, Germany is a country. Based on this logic, it says Berlin is the capital. Okay. Now, so similarly, the regal thing also, right? King, queen. Now, again, in we had talked about biases, right? The word embeddings brings in a bias. Okay, when this was used actually in classifying resumes of male and female applicants. This was a big issue in NLP. You can look it up. Okay, I don't remember which company, IBM, I think. So they had this automated tool to classify resumes of male and female, but because of their embedding, this word embedding thing, so the male applicants with the same qualifications were referred for computer science position. But female with the same qualifications were given for some lower jobs. Okay, so this is the where the fairness that we are talking about, or the bias we are talking about, comes in. Okay, so word embeddings. I mean, we have to keep our mind open that it is very important to look at the data on which it is trained on. This is a multi-dimensional. This is just a visualization to show, more than 200 dimensions. You can have better results when you have that. You can go beyond the binary kind, So coming to sentiment analysis, we'll just go over some of the terms. So it is studying people's opinions, appraisals, attitudes. Okay, we try to understand the underlying emotion in the words that are used to speak or hear or write. So expressions broadly classified into two polarities, positive, negative. And then when we talk about facts, so for example, if I say the movie is directed by so-and-so, it is just a facts, right? But if I say the movie was directed so badly, it is my opinion, subjective opinion, right? So we have some objective facts and we have subjective opinions. So some terms that are closely related to subjective analysis are opinion analysis other than sentiment analysis. Similarly, for emotion analysis, we use the term affective computing. These are the basic features that we are used for supervised corpus. So back of words, unigrams, and grams, like the nearness, like two words together. So for example, if we have a word bad, it has a negative sentiment. If you have word good, it has a positive sentiment, right? But what happens if you have the word not good, not bad? So you have to look at the bigram then. Similarly, most of the sentiment is integrated within the adjective verbs, adverbs that we use. And then punctuation symbols, normally these are cleaned out. In other applications, we clean out all such things, but in sentiment analysis, these are very useful to have some punctuation symbols. Like when we say, I am very happy with many multiple exclamation marks, you are giving the sentiment that you are very, very, very happy. Then these are some of the resources that are available online. Okay, Senti, WordNet, WordNet Effect, General Enquirer, Subjectivity Lexicon. Okay, you have many more like this. And then why participating in conferences or reading is important is that there are always many shared tasks where lots of data sets are released. Okay, so the keeping a track of the shared task, participating in shared task is very important, especially for young researchers. We also have this MPQA data sets, the IMDb, the movie data set, okay, movie review data sets that are available. Now, most of these are available for English, right? We also have to see that we have to have something similar like that for our languages if you want to work in this area. Now, we know that human interpretation of sentiment is very accurate, right? And to do these things for machines, we need to have large amounts of data. So the better the learning is, the better the results. Okay. One second, it's not going to extra. Yeah. So these are some of the applications, recommended systems. Like most of us know that, if you're watching some kind of movies, you get recommendation for similar movies. Similarly, if you go to say Amazon or Flipkart and you are browsing some products, you get something similar also. So this similarity factor is very important in identifying your taste or customizing what you want to do. Similarly, advertisements, if you have Google ads, the kind of search words you give, okay, not just Google but other search engines also, based on your search things, you get, sometimes I feel very surprised. Oh, I saw this, and then suddenly, all the trending things related to that only pops up. Suppose you are looking for some cure for some cough, suddenly your Facebook has products for cough, your Amazon is showing cough products, your ads are coming, YouTube also shows that, you get a little surprised nowadays that, everything is so linked, because not just the pages you're going through, even your device is storing a history of your search. Then we have other kinds of things where the customer management or reputation evaluations. Okay, so even for optimizing staff scheduling, so we use all these things. Okay, so from mails, it reads whether you're busy or you're free, and then it schedules that, okay, these are the three, like Cortana does this, that it says that you have free days, like today, everything being online, our calendars are shared, right? So using the calendar, my personal assistant on Microsoft tells me that I am free for 2 hours today, whether I would like to plan anything. Okay, so all the tools and applications are integrating with the language that we are using today. This is the customer reviews. Again, this is the how a customer gives reviews, right? And whether it is Amazon or again Facebook, you see that we give different ways of expressing our sentiment using stars, and the machine is learning from this, right? So these things will help the company also to improve their products. So for example, when somebody is talking about a mobile phone and giving the reviews, they're giving reviews not just for the whole phone, but they're giving reviews about each aspect, each feature. So a mobile phone, they talk about the camera, the lens, the weight, the size, the screen, everything, the speed, everything, the memory. So a company can also use this data to improve their products. So there are the two works I was wanted to refer to, where the attitude is studied, and again this is the work where US Airlines, based on the Twitter data, US Airlines had this negative, how the sentiment about the service was categorized. So we'll just look at how the work is done. So if it is Twitter data, hashtags are used for collecting the data, and this is the sentiment by airline. So their own sentiment is all positive. So you have this. Okay, so when Twitter is giving, the aspects are about airline, the service, there are lots of other features, right? And then this is collected by number of tweets, and the reasons are given, about the customer service or the late flight, about the time. There are many more reasons here. Cancelled flights, lost luggage, and other kinds of things. So these are the reasons are given, and the day sentiment is collected, and the overall sentiment is broken down into positive, negative, and neutral. So in binary classes, we normally go for positive, negative. In tertiary, we go for neutral. Some people even go for the 5 level one, like 1 to 5, where 1 is the least and 5 is the maximum. And having this neutral becomes a challenge, actually. Many people, when they are giving, when they want to be very what do we call, they don't want to hurt people, right? So they choose the neutral one. So many people, the research gets affected because of this third angle, neutral. Even when you are reviewing papers, we have this 1 to 5, right? 3, when you are not sure, this paper is very good or this paper is bad, you are unable to give the review, you end up giving them the score of 3. So ACL has this, they also have included 2.5 and 3.5 so that, you are very sure to incline. You're 3, but you are inclining towards positive. You're 3, or you are inclining towards negative, you choose 2.5. So there are many common words that are taken from the negative tweets. Again, if the airlines, for example, this study airlines actually took and corrected many of the things based on such study. So we have reviews, right? So we have restaurant reviews, burp.com, we have mouthshut.com for a wide variety of reviews. It includes hospitals, hotels, colleges. Then we have many other reviews by professional critics. So you can explore these things where the companies or the products, the reviews are taken and they are also corrected, basically. So this was a mouthshut.com screenshot for IIT Bombay. Again, these are called the features. So, or when we say aspect-based sentiment analysis, we are looking at certain aspects. Like for camera has certain aspects, movie has certain aspects, right? So here, college will have many aspects like academic programs, administration, extracurricular, alumni network. So based on that, based on how many people are giving the reviews, you can actually judge whether the college is good or not. I'll again, these are again about the reviews about cameras and other things. Just so when we collect data from social media, there are lots of mistakes. So mistakes in grammar, mistakes in spellings, mistakes. Okay, so we have to be very careful when we are collecting data. Okay, so cleaning becomes very important. Then, of course, for English at least, we have many tools, right? But when it comes to our language, we have to create data, right? And this is why I keep saying collaboration is very important among the research groups, because even within the same research groups also, people may be working on different topics, not knowing what the other is working, whether in case it is a similar one also. So working together is always helpful, especially for languages where the data is very less and the work is at the beginning stage. Now, I'll just go over some of the work that I have done, like in monolingual languages as well as code mixed languages. So I will just look at some of the works of my students, okay, recent work, given the time, it is 11:30. I'll just go quickly over them. So these are some of the tools that we use, Python language. We also have libraries in Python that you have to export. Then toolkits like scikit-learn and other tools like NLTK, Python, text, blob. Okay, all these are useful when you have to run some basic parsing, like at the word level, sentence level. You want to do morphological analysis or syntactic analysis. These become very useful. Some basic concepts of text classification as a tokenization, that's breaking down a sentence at the word level. Then if there are multiple spellings, okay, where word normalization is important. And running back of words model, like identifying at the word level itself comes easy, but again we have to go through the bigram model, or then some of the machine learning machine learning based classifiers. And then today we have many pre-trained models, okay, especially neural network models. They're useful if you have large data sets. And then we also have IndicBERT and other such language models that are developed for Indian languages as well. Okay, so this is first work. I just want to give how we worked on this. So initially, like this was like 5 years back, when we did not have much data for Telugu, we tried to use the translation method. So we took data for different genres, and we tried to translate the English reviews into Telugu. Like we took multiple domains like movie reviews, song lyrics, product reviews, book reviews, and then we translated in Telugu. And we got fairly good accuracy. Okay, so for the translated text. Now, while doing this, we realized that, we followed the standard method of normalizing all that. So the data also, the results were also good. But what we saw that in the translation, some sentiment was lost. Okay. So for example, if somebody says, this is excellent, this is very good, this is good, right? So for very good and excellent, it was translated same way. Okay. or it is awful and very bad, So if you are taking this 5-point scale, Richter scale, you see that the 5 and 4 or 1 and 2 were similar, but the translation was giving a wrong thing. So this, for here we try to do it in a, we try to merge highly negative with negative and highly positive with positive and try to bring out the sentiment. So this is another thing, when you are translating, we have to be, we also have to see that the sentiment is also transferred, not just the sentences. So for example, when you are using machine translation systems for reading news, because news is basically objective, fact-based, right? There's no sentiment there, no subjectivity there. But so the machine translation works very well there. But for other things, especially for these things like movie reviews or book reviews and other products like off the shelf, we have many medicines today, right? Today for COVID reasons, everywhere the herbal medicines available, which does not need doctor's prescription. So if you go to Amazon, you have to read reviews about it. Now, if you don't know, say that language, say English, you want to translate it into our own mother tongue and read it. The sentiment has to be translated as well, right? Otherwise, we may end up buying a wrong product. So this we have to be very careful if we are using translation method to create data. Okay, so this was some experiment we tried to do in domain, like we trained on same data set and tested it the same data set. And then we did cross domain, we trained on one domain but tested it on the other domains. So you see that the results were different compared to the in domain one. In domain, the results were better, but in cross domain, the results were a little poorer. Now, here, given the time, I just want to look at other research problems that we looked at. So, given, let me see one of the reasons I like to compare the social whatever we did in social linguistics. So we have this. Many issues with language itself, right? We are talking about social issues, but language itself has many issues, right? We use language for giving insult, like cyberbullying. You see that in cyberbullying, there are lots of hate speech. There's lots of anger that people try to give out, right? And then if our systems are learning on such data. Okay, so there was a chatbot called TAI by Microsoft, which had to be taken down within 24 hours because the chatbot started using very rude language. Now, why? So the developers were very surprised how this chatbot is using such rude language. So the reason is that the system learned a lot from data that users were using. And then in online community, people just use very foul language. So the language that was used by the users crept into the training data sets. And the bot was using bad language, rude language, racial language, right? So it was, you can look it up, this was like 4-5 years back. Now, so there was one workshop in ACL on hope speech detection. Hope speech is the opposite, we are trying to bring in positivity in language. So as part of that, we worked on converting insult into compliments. Okay, so this was one work where we first detect insult and we transfer it to compliment. Similarly, we had work on the gender bias, where we saw that there are, when we say ambivalent, we are talking about two kinds of sexism. One is hostile, which is very easily identifiable. The other is looks more like a compliment. Okay, so it is benevolent sexism. It is still sexism, but it is benevolent. So we try to do this, identifying the kind of sexism that is prevalent in tweets. Then we also looked at, I mean, these are only some of the works I'm trying to present, given the time. So I will just explain and show the results directly. Then sentiment polarity in song lyrics. So we did not look only for positive and negative. We also looked for emotions like happy, sad, and then we had different terms related to that. Then political bias. We see that today most of the political parties have their own newspapers. They have their own news channels, and whatever is given for their party, the news will be biased, so for them and against their oppositions. Right. So, for example, we have a particular newspaper for the current Chief Minister of Andhra Pradesh. So, when he was arrested, there was no article about it at all in the paper. Their channel also just showed some non-relevant article. Like the rest of news channels were talking about it full day, 24/7. They had debates, they had clippings of the chief minister, before he became chief minister, going, being arrested, all that. But their own channel just showed some documentary films, just, did not participate at all. They did not even have any coverage, no statement, nothing. So here we also realize that ignoring is also kind of a bias. Then again, I had mentioned I work in humor. Earlier I worked in translation of jokes, and today I also work in computational humor. So computational humor, again, we touch upon only the lighter things like detection of humor or sarcasm or just a generation of humor. I think somebody's phone, I guess.
Hello.
Yeah. So given the time, this is a background of the work, and I will quickly go over the results. So this is how the number of people using social media platforms in the last decade. See the rise of it, right, in Facebook, YouTube, WhatsApp. So this also has given a scope for online abuse and cyberbullying. Okay, and this also resulted in lots of research in identifying toxic comment classification, hate speech detection, cyberbullying, and our own work on finding out the gender bias. Okay. So here we have data sets. Even our data sets have been released. You have a data set by Wasim and Hovi also, where we took this part for our data. So they also include among the cyberbullying comments, sexist, racist, or neither. Okay, so these data sets have been used by us also, and this negative speech detection becomes very important because it is used for training models. And then our purpose of this work by Ravsimar was to convert the negative speech to positive. Okay, so basically, so something like this, like the insult, you have the facial complexion of a burn victim. This is an insult. This is converted into a compliment. Okay, everything about your appearance is perfect. Now, this is if you see that most of the insult look at the facial features. Okay, so we try to look. I'll just show you the directly. So for these as the attributes, like we took face, hair, eye, head, so insults related to this. Similarly, compliments related to hair attributes. Okay, and then After that, we tried to filter it out into facial, physical, and other, and we ran results of identification of insult, where you can see that ExcelNet gave better results than all others. Okay, so these were the models that it was experimented with. So LR, SVM, BERT, Roberta, ExcelNet, and so here, basically the goal was to reduce hatred in social media, and we can also, though we did not do this, we can also integrate it to raise a flag when suppose you are typing and then it will just raise a flag, or you are insulting someone, or you are it is helpful because sometimes children use bad language. Children, because of all the exposure to social media and with all the Netflix movies having all this foul language, they think it is very normal to use such a language. So if it is part of the language tools that are in their laptop or their PC, you can, or any of the platforms they are using, whether it is Facebook or YouTube comments, it flags. Similarly, it can be, in other words, like the Grammarly, okay, pointing out if any insulting words is used. And also it can be used for machine learning if there are any abusive terms related to religion, race or caste, any insulting, whether it is physical attributes, it can be converted to non-abusive or less rude sentences. The other one, which I talked about sexism, we try to use a different method. Okay, so this again was a motivation from Rio Olympics. Look for it. This was the most sexist Olympics that took place, okay, in Olympics history. Okay, and we try to identify the tweet. We collected lots of tweets. We try to classify them as hostile, benevolent. Okay, and I'll just show directly the results here. So here, we used fast text classifier, sequence to sequence, then SVM, okay, where TF-IDF was used as a feature, and fast text gave us better results compared to all other methods that were used. So it outperforms SVM and sequence to sequence. Okay, the third task I would like to share here is about the song lyrics. And this is a different kind of feature set that we are talking about, right? So it's not just positive sentiment or negative sentiment, but we are talking at the various emotions here. So this is at the valency and arousal. Okay, so you see that these are the negative ones. Okay, so the negative sentiments, and these are the positive ones. And then there is the arousal feature. So the closer to this x-axis, you'll have less arousal one, like happy, pleased. And here it goes to the maximum, astonished, excited. Okay. Similarly, if we on the here, if you go, it is like pleased, it goes till sleepy. Okay, the actions also gets relaxed here. Okay, and again, if you look, somebody is sleepy, somebody is tired. In both the cases, people don't do anything actively, right? When you're tired, also you don't do anything. When you're sleepy, also you don't do anything. Only thing, this has a positive sentiment, this has the negative one. Okay, similarly, when you're excited, there is positivity. When you're tense, you have similar things happening. Okay, but these are the negative things. So we looked at this circumflex, and then we had song lyrics which were annotated for this kind of emotions. And if we look at the results, we were happy with the SVM results here. Okay. There was one more aspect when we are working on song lyrics. We saw that there were lots of English words crept into Telugu lyrics, and very joyful songs or very happy songs. There was lots of English words and sentences coming in. So for that, again, we
Recording in progress.
So this was one motivation where I talked about the political scenario in Andhra Pradesh and Telangana. So this work was, we took newspaper articles and speeches in the 2014 general elections, and we saw and studied using linguistic tags like kinship terms, pronouns, all this, and then we tried to study the speeches or the articles written about the winning candidates and then the losing candidates. Okay, and we tried to bring in statistics, and we saw that so these were the politicians who had taken part. We looked at their data, and we saw that so for example, this person was the winner in those election times. So how the sentiment is in their speeches. Okay, so and then they talk about local sentiment, they talk about request, their gratitude to the people of the land. Okay, the kind of sentences they use are much more imperative, like very action oriented. And then the kind of language they use, okay, related to say kinship terms, like they talk using terms like mother and brother to the mass. All this gives you results of the winning candidate. So here we also looked at the sentiment that the winning candidates would talk more about their own schemes. The losing candidates took their time to actually insult the other candidates. They did not talk about their own schemes or their own promises. They took, most of the speeches were directed against the opponents. And the result was they lost the elections. So this was another work. And finally, last 10 minutes, I'll just give you a brief account. All these things are fine, but when we come to humor, it is much more difficult. Like you will also come across people when you tell a joke, they may not get it, they may not laugh, right? So you can imagine how a computer can understand humor. We all started with the language understanding, and then when the language has humor, it becomes very difficult. Now, my other research is also to integrate humor in dialogue systems. Like I'm working on that, and this is on the side working on at the discourse analysis. Like, so trying to just identify sentence whether it is humorous or not. We are also indulging in natural language generation of humor, but at this point, I would like to just give you examples about humor. Maybe another time I can talk about theories of humor. So here you see that, just to end on a happy note, I will just give you a comparison. See, look at this, where there is a will, there is a relation. Now, this is a humorous sentence because it is based on our uh, our well-known proverb, where there is a will, there is a way. This is our expected sentence, there is a way. But the moment we say where there is a will, there is a relation, this ambiguous word, you realize, oh, this is ambiguous word now. We are talking about the will of a dying person. Okay, so similarly, we have other sentences, marriage is a formality for some and experience for others. This looks non-humorous, but if you look at this, marriage is a word for some and a sentence for others. Okay, now sentence, in the first case, you think that sentence is related to word, right? But now the whole meaning of sentence as a punishment is changed, right? So this is, if you again run a part of speech tagger, you run a parser, you run any of the things, it won't tell you whether this is a humorous sentence or not. Okay. So detecting the humorous sentences as a text classification problem is much more challenging, I feel. Like, for example, in hate speech, at least you can make a dictionary of words like bad words, right? Slang words, abusive words. You can make a dictionary. But here you cannot make a dictionary of humorous sentences, okay? Because there's no dictionary as such. Because in one way, most of the words may be ambiguous, but in that particular context, that punning is what brings out the humor. Okay, so one work we worked on using data sets. Again, it was a very simple work. We did just a binary classes, and SVM gave us better results. Lots of work has to be done again. So to conclude my talk, we went over many things, but I'll just say that, since most of you will be working here on this in this area, we have to try to bring in little positivity into the world with the help of natural language processing. And at the same time, we have to try to, there is lots of negativity in the society. That negativity has crept up in the data. Now this data is used for machine learning purpose, right? That means the models we are training on, there is already bias. So for example, the gender bias also, okay? So there is bias in the training data. Okay, so the bias will be there in the language models that you are building. So we have to make sure the data is unbiased, the data is much more reliable, so that we will have better systems in place. I think with that I will stop. Thank you very much.
Thank you, ma'am. Participants, you can post your queries here in the chat box. Ma'am,
Yes, please.
I have a question that mostly in Twitter comments there may be transliterated text, right? So is there any tool available for analyzing those transliterated text, mainly in low resource languages?
Yeah, we don't have, but we do have tools for major Indian languages. See, the problem is we normally have for full words. Okay, so for example, if you have to write a word care, care, you will have. But how we use in social media, we don't have a consistent spelling there. So you may use a TC for take care. You may use just a CR for care. Somebody else may use CRE for care, right? So there is no consistency. So it's still a challenge. But if it is like full word, like the kind of words we find in textbooks, we do have transliteration tools.
Okay. Okay, ma'am. Thank you. There is there is one Sorry.
Yeah.
There is one question, ma'am. How can we apply sentiment analysis while developing a chatbot?
Yeah, I have given this example, right? The intention. So intention becomes very important when we are looking at dialogue. Okay, so here it is not just one text by one writer. In chatbot, you have both the speaker and the hearer, right? In this case, you have a chatbot and a human being. Now, sentiment can be what the sentiment in the sentences the chatbot is generating, you have a hold on that. You can control that. But what a user gives, right? User may say as utterance, which may have sentiment that the chatbot has to identify. That may be a challenge, right? Because see, when you say when I say a word like what is the time, I have one meaning in one context, right? Suppose I tell the chatbot what is the time, it will say 12 o'clock. Okay, but suppose I tell my son, suppose I tell my son to come home by 10 o'clock. Suppose he went out with a friend and I told him to come home by 10 o'clock. And he doesn't come till 12 o'clock in the night. When he comes home and I say, what is the time? Do I really want to know the time then? No, right? So my intention is you are late. Okay, you were supposed to come 2 hours back. What happened? I was worried. There are lots of meaning now in the sentence. What is the time? So similarly, if you go to a doctor and the doctor says, how are you, right? And if you just say, I am fine, then, it stops there. Conversation stops there. So when your friend or your family member is asking you, how are you? It is more like a greeting. But when a doctor says, how are you? He wants to know whether your symptoms have reduced, whether you're feeling okay today compared to last week, right? So the meaning of how are you changes. So there is the intention that we have to capture. Now, if you remember, I told the damsel, it is dialogue act markup in several layers. So we have worked in dialogue system and we try to bring in, like I'm in my research, I try to bring humor in dialogue system. I try to study this, what you're suggesting, right? Sentiment analysis. So we are trying to combine everything into dialogue system, including machine translation, because today there is so much of bilingualism happening. We cannot just have a system in one language. It has to handle multiple languages. Similarly, I'll just tell, we haven't published any work on this, but I also work on a project where we are working on detection of depression. Okay, so based on so for that we have taken lots of data from certain website. We have data collected, we anonymized the data, and we have those paragraphs written by people who are going through a bad phase. Okay, so this is our training data and we want to incorporate it in the chatbot, where through dialogue, the chatbot will be able to identify whether the user has any signs of depression. Okay, so this is like sentiment analysis is a good research on its own, but integrating with chatbot is really useful because then it becomes dynamic also. On the, as the conversation progresses, the chatbot should be able to identify the sentiment on the go.
Okay.
Yeah.
Okay, thank you, ma'am. And
Thank you.
one more question from same participant, that is, what are the ML and DL techniques for doing the same? The sentiment.
So we have to, like I had shown you a different results, right? So for each sentiment is something else, like for gender bias, fast text work better, ML work better. For something else, another technique worked better. Okay, so sorry. So we have by LSTM working for something, we have to test all those. Okay, we still don't have, I cannot just say that, oh, this is the best for everything. Okay, depending on what we are looking for, we have to work on that. We have to, this is why reading becomes important, right? Reading becomes very important to compare, okay, which ML model worked better for which kind of feature. Okay, we cannot just have a blanket rule that for all only this will work. Okay, so like for something random forest may work well, for something just a simple SVM will work well, for something else, so we also try to do hybrid. We do this plus this plus this, SVM plus this. Okay, so SVM plus by LSTM, a combination of different techniques also we try to do it.
Okay, thank you, ma'am. I think no more queries.
Yeah.
So shall we wind up the session?
Yes.
Ma'am, can you please stop sharing the
Yeah,
screen?
I'm just trying to see. It just says new share. Trying to see. Yeah, pause share will happen. Okay.
Yeah. Okay. Okay. Thank you, ma'am.
Thank you so much. Thank you. I hope I met the expectations.
Sure.
I
Yes.
mean,
Okay.
thank you so much.
So that was an enlightening and insightful presentation on text classification. She very well defined the differentiation between natural language processing and computational linguistics. She explained about different tools for text analysis and generation, and also what all challenges are there in text analysis. She provided us information about various research opportunities in NLP field and also current works carried out in text classification field. Once again, I thank you from the bottom of my heart for taking time from your busy schedule. Please accept a small token of gratitude with our sincere thanks. Thank you, ma'am.
Thank you. Thank you so
Thank you,
much.
ma'am.
Thank you so much.
Okay. Participants, please fill the feedback and attendance in the link provided in the chat box. And we are going to wind up the session. The next session will start on at sharp 1:30 p.m. Participants kindly join at 1:30 p.m. Okay, thank you.
Recording stopped.
Thank you all.